So we were talking about the SCAP, which is we talked about various protocols that come under SCAP, various standards. So CVE is one of them, CCE, CPE. These are 3 enumeration type standards. Then we have languages, XCCDF and OVAL and OCIL. And then there is one metric we said is about the how to measure the severity of a vulnerability. So that's the severity of vulnerability scoring system. So, we were discussing CVEs, and we know that CVEs are actually way to uniquely identify vulnerabilities, and we know that now all the CVEs that have been disclosed and analyzed and checked and given the right CVSS score, and also the vulnerabilities that are identified with the right platforms on which that vulnerability can be reproduced, or CPEs, and the configuration that is required for that vulnerability to be reproduced. So CCEs, all that stuff could be part of this database. And as of yesterday, it seems that there are so many vulnerabilities being disclosed these days that NVD is 6,900 backlogged on analyzing and publishing CVEs. So CVEs are, new CVEs are being published, being reported, and they have to be published, but before publishing they have to be analyzed. The vendor has to be, usually they give time for vendor to actually patch the vulnerability before they are publicly made available. So therefore, it is the situation is that the number of CVEs are getting very, very fast reported, and therefore it has become a problem, and people are saying that there should be better way of handling this than just having a worldwide centralized database. But for now, we can assume that we will find the CVEs for the near future in the NVD database. Now, the next one is CCE, or Common Configuration Enumeration. So now the question is, there are many configurations for every software, right? So for a software like Windows, there would be tens of thousands of different way of configuring Windows, and when we say tens of thousands of different configuration, we mean for its various components. For example, how you actually set up the password system, there would be many different things that you can do. How you set up the backup system, whether you use something like a some kind of a encryption mechanism of the disk or part of the disk, whether you enable that, this all kinds of configurations are possible. Now, when you do all these different kinds of configurations, so normally in a document like XCCDF, so we said that XCCDF is the standard for configuration benchmarking, right. So I want to say that this particular configuration for IIT Kanpur CSE department should always be this, and this configuration should always be this, right. So I want to say such things in an XCCDF document, so that it becomes a benchmark. So then everybody can actually check that against that benchmark, whether they are up to the required compliance of what IIT Kanpur CSE department requires, right, in terms of the configuration of all their Windows 11 machines or Red Hat so and so version machines, right. So there will be separate benchmark for each of these kind of systems and each kind of software. Now, how do you identify uniquely which configuration you are talking about? And that is where an identification number is given through this CCE enumeration. So you can see here that, for example, here is a policy which has been given a unique name, right. So, this policy is about what should be the behavior when an unsigned driver is being tried for installation, right. So, suppose somebody is trying to install a driver software which is unsigned, right. So, unsigned means that it has no digital signature on who created this driver. Now, that is a pretty dangerous thing to do. Now, in a regular laptop, when you are actually buying and using it at home, you do not think about this configuration, right. Most probably this configuration is permissive in your machine. That is, it is saying that any driver you want to install, if you are thinking you should install it, it will let you install, or maybe it will ask you for permission, right. So, one of the two will be the behavior. So, here this configuration setting is named CCE 3085-8 here, and it's you see that what should be the behavior. So, you can set this behavior in this registry key, right. So, it is a registry key and it is often defined by the local or group policy. We are talking about Windows here, and then so, but this CCE does not say what should be the behavior, right. It only says that this is something you must configure, and when you configure this, you can use this string to identify what you are configuring. Now, particular benchmarks, for example, this is the defense benchmark, this is the National Security Agency benchmark. So, this one saying is that it will tell you what should be the value for this key, right, and this guy will say what should be the value for this key. So, in this case you see that the behavior is that you warn, but allow installation. So, a warning will be issued to the user that you are installing a driver which does not have a signature, but if the user wants to go ahead, it will be installed. But in a very critical system, you may actually have this that deny, right. So, if it is an unsigned driver, then you have to deny it, right. So, that would be part of the benchmark. So, similarly here you are saying you are talking about a particular configuration that users prompted to change password before expiration, right. So, the number of days prior to expiration is what is the parameter to this policy setting, right. So, what that means is that if your password is expiring in 2 weeks, if your policy is set to be like 2 weeks, you will start getting the warning that your password is about to expire in 14 days, 13 days, 10 days and so on. And as soon as you fix it, as you change the password, the warning will go away, because then this thing will not be triggered. So, this is the password expiration value may be set by your organization or by the standard benchmark, like for example, DISA benchmark, and similarly NSA, if you are setting according to NSA standard, then it will be 14 days. Similarly, shut down the system immediately if unable to log security audits, right. If you are not able to log, sometimes you see your log is not being stored or something for some reason, then what should be the behavior? One is to actually shut down the system, another is to actually continue, right. So, this is enabled or disabled would be the parameters for this particular setting, and then it would be also can be done through the registry keys, and you see that in case of NSA it says shut down the system immediately if unable to log security audits. This has been disabled, right. So, in this case this is disabled means that you will continue to operate even if the log is not being stored. So, this is a choice. So, the main point here is that CCE does not tell you what should be the policy, it only gives you a handle on the setting that you have to decide on, right. So, how many days before password expiration you will get the warnings, or whether you are allowing unsigned drivers to be installed, or whether you are going to continue when there is no log being stored, etc. These are what the part of the CCE. CCE does not say that allow or disallow unsigned installation, or allow or make it 15 days or 30 days. That is not part of CCE. CCE just gives a name to these policy settings. What should be the value of those policy settings, of the configuration settings, is based on the benchmark or the what we call STIG, or Security Technology Implementation Guide. That will tell you what should be the setting, right. And you could also write a manual in PDF or other form to tell what the settings should be, but then somebody has to go and sit down and actually do all this setting, and there will be thousands of settings. It will be very difficult. So that is where a tool like WESCAP will allow you to automatically apply those settings based on the automation that you do through the benchmark like stick files or Security Technology Implementation Guides. So CCEs do not actually have recommendations, so they are policy neutral. They do not decide what should be the value of these settings, but they only identify the settings. And CCEs do not map to just one way of controlling a configuration. It should be procedurally neutral. Whether you want to do this through a registry key or you some other mechanism by running some kind of a script or something, that is up to you. And it's not platform neutral, of course, because different platforms have different configurations. So this the configuration names, these names are specific to Windows. For Linux and all, there will be other CC numbering. So it gives you a way to understand what the policy is supposed to configure. Yes. No, so it keeps getting added. So today what you have in CCE, 1 month later there will be some new ones added for new software and all this stuff, right? I see. Okay, so there is a NIST page on CCE, and it has a list of the CCE numbers and what they mean and all that stuff. Is that what you are asking? No, so that is an example, right. So this what you are seeing as technical mechanism is not part of CCE. This is just this table is not part of CCE. This table is just to show you, like, see, this is basically, these 3 columns are basically specific to CCE, right. That what is the ID, what it is, what parameter, what configuration we are talking about, what are the possible values of the, what are the things that you need to set, right. The rest of it is just to illustrate what this could be, or how to set it, or when it is set, what would be an example setting, things like that. Okay, so you can actually search for it and go to the website and look at more examples of these, right. So CPE is another way of is a way of uniquely identifying the platforms. The platforms regarding you know what you are talking about, right. Whenever you are talking about some CVEs, for example, when you are saying that there is a vulnerability, you have to uniquely identify which platforms. For example, you can have a vulnerability that only applies to certain version of Windows 11, not every version of Windows 11. So you have to specifically say what versions of Windows 11 are affected by this CVE and which versions are not affected by the CVE. So therefore, this CPE is a common platform enumeration. The way it is done is you basically use the term CPE, and then sometimes you actually also see version, because CPE has gone through versioning. So you can say CPE 2.1 or something, Then you say what is the part that you are talking about, whether it is a operating system, whether it is a hardware, whether it is an application, etc. Then you have to say what vendor it is from, then you have to say what product it is, then you have to say what version you are talking about and which update of that version, because each version may have multiple different updates. It may also have multiple different editions, and it may be actually a language version. So, for example, you can have a Chinese version of Windows versus a German version of Windows versus a US version of Windows and stuff like that. And then for the part, the choices are O for operating system, A for application, and H for hardware. And if you leave any of these things empty, that means basically that is a wild card. That means that any, like if I keep the version field empty, then I am talking about all versions of that particular vendor produced product, right. So examples. So here is let us say Windows XP Service Pack 1, right. So we are talking about part is operating system, the vendor is Microsoft, the product is Windows XP, then version, you are skipping the version. So there is an empty block, so skipping the version, and then update. So this is the Service Pack 1. So those who have, I guess most of you have not seen Windows XP. So there was Service Pack 1 at some point, and then they had Service Pack 2. So that added features and fixed certain things and all that stuff. So this is Service Pack 1, and rest is empty, which means that it is true for all editions and languages and all versions, right. So basically we are talking about Windows XP Service Pack 1 irrespective of what version, what language, what edition, etc. Similarly, here is an application. So here is A for application, the vendor is IBM, and then this is Tivoli configuration manager, and this is the version is 4.2, and all updates, editions and languages we are talking about. So if you see this as a CPE for a particular CVE, that means that CVE applies to all the versions and all the editions and languages if they exist, if different language versions exist. So it is used for automated software inventories. So when you actually do software inventory, you do various kinds of asset inventory, you can actually use CPE for uniquely identify them. Also you can map the platforms to vulnerability or policy statement. So you can talk about both vulnerability CVEs associated with CPEs. Also when you do configurations CCE, you can say which version we are talking about. There are many CPE names, there is also a database there, and also all the NVD entries are annotated with the CPE information. So this is now CCE version 5 going on. So all platform groups combined file. So this is an Excel file. So you can see CCE number, name, all these things. Now this also tells you where this which security implementation guide like talks about these configurations. Like for example, PCI DSS, which is the security standard. So this is the like for example, this is showing in PCI DSS, which is a standard for credit card related information. Anybody who is taking credit card for payment on their e-commerce interface or whatever, they have to comply with PCI DSS standard, right. So this says what are the settings that are associated with the PCI DSS. Not all of them are related to PCI DSS. Similarly, it says what HIPAA is the health related information privacy protection standard in the US. So HIPAA talks about certain configurations, COBIT talks about certain configuration, ISO 2700 let us see, this is 27002 talks about this configurations. This is 62443. So, it is a very comprehensive mapping of all the different configurations and which configurations must be set to specific value according when you are trying to comply with one of these. So, if you are trying to comply with HEPA, then these CCEs are relevant to you, and there's what setting they should be is defined here, and similarly for PCI DSS or 27002 or 62443, etc. So, this is a very relevant document for cybersecurity teams that are trying to be compliant with certain standards or required to be compliant with certain standards. So, now if we go to the CPE list, so let us see, now this you can see also that there are different tabs for different types of software for which these CCEs are defined, right. So, you can see that therefore Apache and Firefox and HPUX and various versions of browsers, Mac OS, various versions of Mac OS. So, all these different software operating system and applications, they have certain designated configuration parameters that have been identified here, and based on this configuration parameters, if you are going to be compliant with certain standard, then you have to set those configuration parameters correctly. So, now if we look at the CPEs, so this is CPE dictionary. As you can see that even in a zipped format, compressed format, it is about 20 meg. So, it has a lot of different CPEs, lot of different platforms enumerated in this. And if you go to the NVD database, and let us say look at some vulnerabilities, let's search for vulnerabilities. So, now it is checking. Okay, so let us look at this CISA known exploited vulnerabilities. And then let us choose. Okay. So, we just randomly pick one. So, this is let us look at a critical vulnerability, right. So, this is a critical vulnerability 10 CVSS score. This is a brand new vulnerability and it is coming from the Cyber Information Security Agency, Critical Information Security Agency, CISA, and you see that well, we will talk about how the CVSS is computed soon, but let us see what are the CPEs. You see that this is Palo Alto network, right, a particular OS, PAN OS, and particular version, but all editions and everything is included, right. So, this particular and then version 11 also. So, this particular CVE of severity 10 is going to be is affecting all these different platforms. So, if your asset inventory had your Palo Alto firewall identified with this CPE enumeration numbers, then you can have an automatic script tell you as soon as this vulnerability is discovered and announced, it can tell you on your dashboard that your this and this software system has now a criticality 10 vulnerability that you need to patch, right. It also tells you, it's in the CISA's known exploited vulnerability catalog. You can find more information like from the vendor, you can find some information about exploits, and you can also find third party advisory on this. Now, coming back to it is undergoing some reanalysis, and seems like they are not very sure about this vulnerability. Something has probably come up, but right now as far as they are concerned, it is criticality 10, and this is the what we call the vector of attack, and we'll come to this vector of attack very shortly. So that's how the CPE is related to this vulnerability CVEs. Now there is also another thing, this is called the common weakness enumeration, right. So the common weakness enumeration is not associated with a product. So CVE is always associated with a particular product and its particular version, etc., right. Common weakness enumeration is another product from MITRE, which basically tells you what are the common weaknesses in software. So for example, improper neutralization of special elements used in a command. So it's a command injection, right. So it's CWE 77. Now you are leaving the we are going into the MITRE website, where there is a common weakness enumeration. So it tells you more about the types of mistakes in software that you keep, right. So this means that, so command injection happens when you actually type in something through maybe a web interface or through some other interface, or through an API, for example, for an API call, where you pass a string, right, and the string is eventually used as part of a command on the shell, right, or on the system. Now if you do that, now the software on the back end, when the user uses a command, the user uses a string either in the API call or in a form in case of a web application, etc., that goes to the back end, and in the back end that particular string is split or something and used as a part of a command, right. Now if you do not check if the string that is being written by the user as it goes to the back end, in the back end if you do not check that this is not a malicious string, if I use it as a part of a command, it can actually backfire on me. If you do not check that, then we say that we did not do the input sanitization. We did not sanitize the input before actually using it in the back end. So CWE 77 talks about that kind of mistake in the back end program. So it's the improper neutralization of special elements, such as scripting command, for example, used in a command. So this is a command injection vulnerability. So similarly, you can have a whole list of CWEs. So top 25, for example, will tell you what are the different most common mistakes in software that people make, like out of bounds write, right. So this is common, like if you are doing writing in a loop and you have an array, if you do not if you are not careful, you might write beyond the boundary of the array, and that could corrupt your stack. Improper neutralization of input during web page generation, improper neutralization of special elements used in an SQL command, so SQL injection, use after free, that is for pointers, improper neutralization of special elements in an OS command, this is a OS command injection, improper input validation, out of bounds read. So these are the 25 most common software weaknesses enumerated. So CWE is not part of this standard. It's just a list that has been researched and created by the MITRE corporation to actually, and it is very commonly used. And as you can see that even in the NVD database, corresponding to a CVE, they mention what CWE it is, right. So what weakness was actually there causing that particular vulnerability. But CWE, to remember, is that CWE is not specific to a particular software or platform or application, etc. Okay, so now we go back to the SCAP, and so we talked about CPE. So now let's see. Okay, so CVSS. So we talked about 3 enumerative standards, right. So we talked about CVEs for vulnerability enumeration, we talked about platform enumeration, CPEs, and we talked about CCEs or configuration enumeration. Now the next standard we are talking about is how to measure the vulnerabilities danger of a particular vulnerability. And there are, so given a vulnerability, I have to score and say, okay, this vulnerability is of low severity or medium severity or high severity. That is what I want to do. Now there are, to do this, there are 3 different parts of this. One is called the base, another is called temporal, another is called environmental. So it's better explained when I actually do it, right. So I go to the CVSS website. So I go to a CVSS calculator. So CVSS calculation also has gone through number of different versions. So right now we are in version 3. So you see that when I get a vulnerability, let's say I find a vulnerability in a software. So how do I go about assigning severity to it, right? So I'm going to see whether this first thing that I'll check is whether this vulnerability can be exploited from the internet if my software is somehow accessible from the internet, or is this vulnerability only exploitable if you are in the adjacent network, that is you are in a network segment that is connected to the next network segment where the software is being run, or do you have to be local, which means you have to be in the same network as the software, or do you have to be physically on the machine on which the software resides. Now which one is more dangerous, right? If the vulnerability can be exploited from the network itself, that is much more dangerous because lot more people have now ability to exploit it. If it is not accessible from the internet or cannot be exploited from the internet, but can be exploited from the adjacent network, then also the number of people who can potentially exploit it is higher. If you have to be on the local network, then the number of people is still reduced, and if you have to be physically on the machine to exploit the vulnerability, then that will give you a much lesser opportunity to exploit. So let's for just example, I say that my vulnerability is exploitable from adjacent network, not from the internet. And if it can be done from the adjacent network, of course it can be done from the local and physical access, right. Now I want to also see whether the complexity of the exploit, to exploit it, do I have to know a lot of technology, lot of techniques and so on, or technology complexity, or is it like very simple, right. So I can just type in something on the network and on the internet some interface and it will be done. So let's assume that it is of high complexity. High complexity means this vulnerability is difficult to exploit. So its severity will be again reduced, right. Then I am saying privilege required. Do you need to be a high privileged user to exploit the vulnerability, or you can be a low privileged user, or you can be no privilege, that is you may be from the network, from the internet, right. You do not have any account on the system or anything, and you can still exploit it. If that is the case, then that is a big problem, right. So, let us put this in none, that I do not need any special privilege, and then I have say whether it requires user interaction or it does not require user interaction, and by user interaction we mean victims interaction, right. So, 0 click, is it a 0 click vulnerability or not? So, let us say it does not require user interaction. Now, there is something called scope. Scope means, scope has two choices, unchanged or changed. So, unchanged means that if the vulnerability is in machine A, will the effect be on other machines, or will it be only on that machine if you exploit it. So, let us say the scope is changed, that is I can affect others, and then I am asking whether if it is exploited, will the effect on confidentiality be high, low or mid, none. Let us say the confidentiality effect is low and integrity impact is high and availability impact is low, right. So, let us see what is the score. So, with this I am getting a score of CVSS base score of 7.5, and the what we call the vector, the vector basically says attack vector is adjacent network, AC, that is the attack complexity is high, the PR privilege required is N, that is none, the user interaction is none, and then scope is changed, and the confidentiality impact is low, integrity impact is high, and the availability impact is low, right. Now, let us do some changes just for illustration. Let us say it requires high privilege. See, the severity went down to 6.8, because if the attacker needs high privilege, that reduces the possibility that an attacker, any Tom, Dick and Harry can do it. Now, let us say I say that you have to have physical access to the machine to exploit this. So, as soon as I do that, it becomes 6.1. Now, if I say that confidentiality impact is none, it becomes 5.5. If I now say availability impact is none, it becomes 4.7. And then if I say user interaction is required, then it is 4.6. So, you get the idea that more difficult it is to exploit by requiring physical access to the machine, for the user to have high privilege, for the attacker to have high privilege, the attack complexity being high, user interaction is required, scope gets if the scope is, if I make scope unchanged, then it is even less, 3.8, right. So, if the scope is unchanged, that is only affects the machine on which you are doing the attack, all that, then you can actually the severity becomes low. Now, let us maximize the score. Attack complexity is low, privilege required is none, user interaction is none, and then scope is changed, the impact is high and high. So, now I have a severity 10 vulnerability, right. So, this is the base score. Now, see, the base score basically says that I do not know anything about what is happening in the world, or I do not know much about your own system's configuration or your network configuration and so on. I am just thinking of the vulnerability in the worst case or best case. Now, temporal score basically says that over time a particular vulnerability may be exploited more and more, because the exploit becomes easily available, right. Anybody can write an exploit, or anybody can buy the exploit, or anybody can download an exploit. So, let us say exploit code maturity, let us say the exploit code maturity becomes high, right, and remediation level, that is the fix from the vendor has not come in yet. Let us say fix is unavailable, right. And the confidence of the report, that whoever has reported this vulnerability, they are not very confident that this is indeed a vulnerability. So let us say unknown, right. So now you see that I have, because of that unknown, my thing has reduced to 9.2, right. Now if I make it confirmed, then it will go back to 10. So now if I say okay, official fix is available, but I say that temporary fix, then it has become 9.6. Now if I say that the exploit code is just unproven exploit exists, then it becomes 8.8. So you see that this, now if taking into account the possibility that yes, there is a vulnerability that can be easily exploited from the network and does not require the user interaction, it does not require the attacker to have high privilege, scope is broader than just that machine. So I see a high severity, but then I see that actually exploits are not that commonly available, and I am seeing that but on the other hand, the fix that is available is also not a proper fix, it is just a temporary fix, and but the report is saying that it is confirmed, then the score becomes lower. Now if I say that the fix is not available, then it becomes 9.1, but if I say official fix is available, then it becomes 8.7, right. So official fix is available means that anybody who wants to protect themselves can protect themselves, right. So temporal factors will reduce or increase the severity. Usually it will reduce the severity, except that when maybe the official fix is not available, etc. Now the third part is the environmental score. The environmental score means that within your organizational environment, is it that what is the importance of this vulnerability and what is the how the attack vector will be affected. For example, I may have a very good perimeter security. So even though my original vulnerability could be accessed from the network, but in my organization you have to be in the local network to exploit this vulnerability. This is possible. Similarly, attack complexity, it may be the attack complexity may be low, but in my organization if you want to access that particular software, you have to go through a number of hoops. So attack complexity also becomes high. And then in my organization you do not access that particular part of the network unless you are a high privilege user. And then in my organization you may require no interaction, but the scope will be unchanged because I have very micro segmentation of my network. So if you do exploit me, it won't spread. And then here I basically say the data that I have in that machine on which this vulnerability exists, maybe these things are low, right. See, the importance of that machine is not that high, and the confidentiality requirements are also low, low and low. So now let us look at what is the, see now you see that just because of environmental factor, a 10 severity base score has now come down to 2.1, right. So environmental factors will also be very important because of this, because your environment may be very well designed and well secured. It has been properly segmented, it has proper use of firewall rules and maybe intrusion detection system and high level of user authentication, two-factor authentication, and only high privilege users have access to the segment where this particular software is located, and all that mitigating factors could actually bring down your severity tremendously, right. So that is what I wanted to say about the CVSS. So okay, so let's next class we will talk about the rest of the this cap. Okay. I think usually that is the case. However, in some cases, I think in case of temporal, if the maturity of the exploit goes high, yeah, so I think still it will be less than the base core. Right. So the base core gives you an upper bound, and then you have to play within that. So base core assumes that you have no the base core assumes that you have exploits available, access available, all that stuff, right. So then you have other this environmental and temporal gives you more information about the context.